Hello and welcome everybody to our Wednesday continuing virtual Connect series. We hope you are able to join us today. Take a little break from the news. Whatever hour you got for daylight savings time of extra sleep, you probably blew through that last night watching some election returns. So welcome back to the regular schedule. And we've got a great message to hear today from some of our longtime partners in the industry. Today's session is called Be Well, Health Focused Solutions for the Built Environment. And it's hosted and sponsored by IMEG Corporation. In case you missed another bit of news from this year, IMEG includes Monroe and Newell. So just at the very end of 2019, that merger took place. So you may know IMEG more locally as Monroe and Newell. So we're pleased to have them as part of our team presenting this content today. You'll receive, as an attendee, 1 HSW credit for attending today's session. And you can use, as always, the Q&A function to interact with our panelists. And we look forward to hearing those questions as they come up. And we'll have time at the end to get to those questions. But I'm really looking forward to this. Obviously, the built environment is important, no matter who's in office, and that work will continue. And of course, it's great when we can do it well and make the people who use that space feel well. So without further ado, I'm going to turn it over to our two presenters today. We have Adam McMillan, who's joined us. Hi, Adam.
Hello, Mike.
And Tammy Dyce. Hello and welcome, Tammy.
Hi, Mike.
Okay, you guys have the floor.
Thanks, Mike, and thanks everyone for joining. Yeah, we're really excited to give this presentation on Be Well. So yeah, for just quick introductions, my name is Adam McMillan. I lead sustainability for IMEG. I'm actually located in Chicago, but support projects throughout the region. And with me is Tammy.
Hi there. Yeah, I'm a senior lighting designer here in Denver, and I'm excited to bring some information about lighting and wellness.
Yeah, so quick learning objectives are here on the screen. I won't read them through, but it is focused on wellness and wellness design techniques for the built environment. And we are focused on the workplace and office, but these techniques can certainly apply to really any type of built environment. So we'll talk about that, clean contact. You hear a lot of reference to COVID-19, but we think more broadly than that. This is general wellness for any illness, viral or bacterial, and future pandemics. So keep a broader view on that. But we will talk about some COVID-specific items. And then we also hit on biophilia. So the way that we're going to do this is we're going to take a tour through a typical office space. And along the way in this tour, we'll be talking about these topics that you see. So we do carry these icons throughout the presentation just to kind of give you a frame of reference about where these apply. While some of these topics we'll just talk about in the lobby, for example, they also apply to conference rooms, open offices, or classrooms. So keep a broad view on that too. But these are the primary focus areas for us. They're all related to wellness. A lot of these are in step with the WELL standard. We're not necessarily saying this is exactly what you do to meet WELL, but we do have that as a general guide as we move through it. Okay, so we'll start here with reception and lobby. So now as you go back to your offices or you go back to other buildings or even start to maybe travel a little bit during pandemic or post-pandemic, really the first impression that you're going to have or people come into your space is going to be the reception lobby. And it's going to feel a little bit different. I think your viewpoint walking into these spaces is, what's going on in here? Is this safe? So as we design these spaces, we want to make sure we have as many welcoming elements as we can to help make it more inviting. So in this section, we'll start with clean contact, then we'll move on to daylighting techniques. So with clean contact, so you walk up into a space now, I'm indoors now, what do we know? So in general, viruses can spend up to 3 hours airborne. They can be on surfaces for up to 72 hours. And certainly cleaning and disinfection is a very important part of that. And that's something a lot of building owners are doing. But what can we do further? What interventions can we make to these spaces to help people feel even more safe? So in our bathrooms, we've been doing touchless bathrooms for a long time in terms of those faucets and fixtures. But now we're talking about having where you can wave and open doors, or even on the bottom right here, this is a little bit of newer product, but toe kicks to call the elevator instead of touching the button. So these are all just very visible interventions that help people think and know that, hey, this is different. I do feel safer. So some things to think about there. as far as riding elevators, this is a pretty interesting infographic from Tyson Krupp. And it talks about some certain things about this entry sequence and how it might be different. I've gone back to our office a few times, and I definitely look to take the stairs instead of the elevator. That's certainly a way to go. We've talked about the irresistible staircases in our architectural designs in our lobbies anyway to encourage that from a wellness aspect, but that would also now apply to our current situation. One of the most interesting / awkward areas that might come up is the elevator itself. So when people used to crowd in whenever there wasn't a square inch to spare, that was awkward. Now with COVID, it's going to be more awkward. So how do we tell people about, hey, this is too full, I'm not comfortable with that? So some things we can do for a design here, they have these sticky pads, or maybe you have foot marks or some way to indicate that, hey, this is the proper amount of spaces that really should be occupied in the elevator right now during the pandemic. So a few design touches that we can do to help minimize anxiety in the space. The other thing we talk about is thermal imaging in the space, and we definitely have heard a lot about thermal imaging. And the idea here is that if someone has an elevated temperature, that can be detected. And to people walking into this space, if they know this is being watched, they'll feel safer going into the space, because this communicates, hey, I'm a building owner, I care about the people in here, we're going to watch to make sure we have a safe environment. A couple caveats with this though, this thermal imaging, while we've used it for a lot of years for to do building envelope testing and things like that, that's a fairly wide range in temperature. Your temperature for your body temperature is fairly minute, and our understanding is the technology is not quite there yet. It is getting better and they are working on it, but it's not quite fully there. As an aside, when I went a few weeks ago to do my early voting, they had one of these there. I stepped in front of it and said I was 92.4 degrees, which I thought, well, that's definitely not 100, but it allowed me to go vote. But the accuracy of that, a little suspect. So there's a wide range of where these are at. So as our owners talk about it, this is kind of where we should be thinking about it going forward. So next point, daylighting and views. So this is just in general wellness. We've been talking about daylighting in our communities for last 10, 20 years. And there's really good reason for that. I mean, we spend over 90% of our time indoors. And we know when we have daylight, it impacts our mood, our circadian health, our productivity. And the studies are very, very strong on the direct link between daylighting and views and performance. And we all know when we get out and go for a walk in the afternoon, what that does for our mood. Part of that's movement, part of it's air quality, but daylight's a really strong aspect of that. So what can we do in our environment to make sure we bring the daylight into the space and receive all these physiological, emotional benefits? And one thing that's really helped us lately is the tools have gotten a lot stronger to analyze daylight. So we can go straight from our Revit models to these mappings where we can be analyzing daylight within a few hours. So this is just a very simple map to show, do I have enough daylight in the space? A spatial daylight autonomy is just kind of that check. Do I have usable daylight? So very simply put in this graphic, orange means, yep, I'm good, I've got enough usable daylight. Green and blue means I don't have enough. And if we want to get those spaces daylight, now we can replace, you can change the size or location of windows, change the window properties, change our surface reflectances, and there's a whole host of strategies that we can use to do that. And the tools make this very easy for us early on. Now, kind of the flip side of that is annual sunlight exposure. Basically, am I getting too much light or do I have glare? And this is also easily analyzed by the software. And in this case, red means I get too much. I mean, we're talking over 1,000 lux for over 500 occupied hours of the year in that case. That's just way too much direct sun. So we need to come up with design strategies for that. Looking at this, interior blinds is certainly one way to deal with that. So this plots the interior luminance during different times of the day and different times of the year. Again, red is bad. So we got a lot of areas with bad glare. Now we do close the blinds and now we see that, hey, we've taken care of a lot of those spaces. And so that's a good thing. You can still see some areas in red. So either we got to come up with some other interventions for glare in those spaces, or we just make sure that we don't seat people directly in those red spaces because we know there's going to be a problem. So here's an example of some simulation up front that can cause, can take care of issues that would have happened down the road. So just kind of in summary here, this entry sequence is going to matter to people, and what can we do? Daylight, glare, view, and privacy control. These views to the outside are really important, and these reflective surfaces really can help a lot. Even in this picture right here, you can see how that floor is reflecting, getting daylight really deep into this space, so that's a good thing. And then finally, natural ventilation outdoors. We're all working from home. I'm working from home. It's actually going to be 70 degrees in Chicago today, so my window is definitely going to be open, and that makes a big difference for comfort and for our connection and our overall wellness in the space. And we don't do that in our offices typically, and I think going forward we might consider it more strongly.
Thanks, Adam. So moving into the open office environment, which as Adam mentioned, we spend a majority of our time indoors. So this can be an area where people do experience a lot of time in their day. And here, we're going to touch on air quality. We're going to come back to that. And we're also going to look at lighting for circadian support. To design lighting for circadian support, we understand that when our circadian rhythm is in positive entrainment, there's a lot of health benefits associated with that. And we also understand that negative entrainment of our circadian cycle, or missing sleep, as I'm sure some of us may be experiencing today, can have some negative effects in our life. And so what we're going to look at is the design of circadian lighting systems, how to incorporate daylight and electric light, and what those quantities and metrics are that are important to cause a meaningful change in our circadian rhythm, and then some of the science behind it. So we have understood over the past 20 or so years that there are cells within our eyes. We know that we have rods and cones, but we also have intrinsically photosensitive retinal ganglion cells, or for short, IPGRCs. And these are photosensitive cells in the back of our eyes with our rods and cones that do not facilitate vision. They facilitate something else in our life. And we've studied over the past few years and learned that these cells, they trigger our circadian clock, which regulates hormone imbalance or hormone balance in our life, our sleep-wake cycle, our mood, and our emotional state. And so what we've learned is that there are action spectrums within within these cells and the way they react. And one action spectrum is here around 465 nanometers. And this is a precise wavelength that helps to suppress melatonin production, which means we wake up. And this is a wavelength that we can try to target for certain times of the day to help regulate that sleep-wake circadian cycle. We do this within our interior environments by carefully considering the intensity, the output, and the color of lighting within our space. And we understand, we know that LED sources are available in a variety of color temperatures, from warm to cool. And what we like to show here with this slide is down in the lower right-hand corner, you can see what we call the black body curve. And it's this black curve on the color chart, which shows the perfect color of light, light that's emitted from our perfect source, the sun. And so in the upper part of that image, you can see where a lot of times to change the light source color, the technology will go in a linear line from, say, 1800K up to 6,000K. And that line, when it's directly linear, you can see where it starts to fall off the black body curve around 3,000, 4,000K. And what we see there is a color shift in those colors that tends to be more pinky and orange, away from that black body line. So it's important to consider quality of sources here and really trying to get that line closer to the black body curve so that when we experience these variations in dynamic white color in our space, they feel natural to us. A case study we have here is our new redesigned office in Chicago. And so this has just been installed. This is literally a cell phone picture from the installation. And so what we have here is lighting within the open office that's been designed for circadian support. The yellow lines are the illuminated sections, and the blue lines are acoustic sections that we used as well to control some of the acoustic quality within the space. There's two methods out there to measure and determine the effect of a lighting system on our circadian system. And so, this can take into account daylight and electric light sources. One method here is the Circadian Stimulus, and this comes from the Lighting Research Center at Rensselaer. And this method takes into account the color, the intensity, and the amount of light that's present at our eye in order to determine a certain stimulus. And the LRC provides us these stimulus guidelines to try to hit to determine whether the lighting system has the ability to support circadian entrainment. On the right side here, we show EML, which is equivalent melanopic lux. And this is a way of measuring the sensitivity of light on those IPGRC cells. And so this calculation is weighted not for the effect on visual light on us, but the effect of the non-visual stimulus on us. And so this was actually the method that we used to design our lighting system in Chicago, and these were the targets that we intended to achieve. This is also in line with the Well Building version 2 standards of how they determine a circadian stimulus. And so we elected to use this metric in the design of our office, and we gave a summary here of some of our results that we expected, or that we're expecting. We are working directly with PNNL on research, continuing research in this space. And so this is an output of some of the calculations that were done during design to determine what kind of EML we could achieve with the lighting system. And this was done with PNNL's alpha software. And so we're working together with them to really use this as a case study to determine whether we achieved the targets that we were out to achieve, and then poll the users over time and perhaps even make adjustments or come up with stronger recommendations on how to support circadian stimulus in these type of environments. So this is an example of, again, our EML targets, and then a schedule that we came up with of lighting that could support circadian entrainment. And so this is an example of a schedule, and we may find as we continue to study this particular case study that we might want to make some adjustments, whether in color temperature or in output or times of day. And all of that can be really dependent on the users in the space, what the schedule of the space is, even the age of the users can change this schedule. So this is really just an example of how we are using our space in Chicago.
Great. So now we're going to move over to shift gears a bit for air quality approach, or talk about air quality. So generally, similar to lighting, high air quality also improves health and productivity. And whenever we do have a fully closed buildings, it's not uncommon for our indoor pollutant levels to get higher than our outdoor pollutant levels. That's why we ventilate our building. High filtration, doesn't really capture all pollutants. So we want to think about how we can best remove them from the space. And really, there's a couple areas we'll talk about later with filtration and UV and other aspects. But for here, we're really going to talk about how are we delivering the air to the space and how does that make a difference in the air quality. So what are the benefits from air quality? I mean, we know what an ideal carbon dioxide level could be, 600 parts per million. We know the ventilation rates that will get us there, and we know where we should be keeping our VOCs. Code compliance or air quality standards certainly help, and they get us, most of the way there. But if we think about creating a superior indoor environment, we want to, shoot for these targets that we're showing here. And whenever we do that, we can see a much better in terms of crisis response, information usage, strategizing, all those things that are really important to an office environment. And, the research is very strong on this as well. So designing for these targets and figuring out how to do it in a way that doesn't, negatively impact energy performance is a really good goal, especially for the office environment. So what do we care about in a space? What are we, what are we concerned for? And here it shows three main considerations. So the first one is VOCs. So VOCs can come from paints, they come from floors, they come from all those red list materials that LBC talks about. They can come from what we wear into the space as well. So that's our first consideration. The second is CO2. We want to emit CO2 so that we can breathe. And one system that's very common is a VAV system. So we put these in buildings all the time. They fully meet code compliance. Some of the benefits are they're cost effective to put in. People are familiar with them. They're very flexible when spaces need to change down the road. So there are a lot of benefits. Another one too is that, they do tend to make a room very thermally equal. So all the temperature in the space is all relatively the same. The downside is that part of that is that it pushes this air from the top and it's trying to create a very mixed thermal environment. But whenever we do that, with all these pollutants that we've introduced into the space, we effectively just kind of mix them all around like confetti. And, this is the reason why indoors we need to wear masks right now, because when we do blow all these particles around, they can very easily go from one person to the next. And it's not ideal from an indoor air quality perspective. So what's an alternative for this in the office environment? So displacement ventilation is a primary strategy to improve the indoor air quality. In this example, we actually show this underfloor plenum system, a UFAD system. This could also very easily be a sidewall diffuser that then kind of puts the air out at a low level. But the general idea here is that rather than forcing this air and blowing it away around at the top, we can just introduce this air, very cool, clean air down to the floor. And it just fills this room up like a swimming pool. And as it starts to fill up this room, it'll now just push these particles all the way up to the ceiling where the unit can then suck them back and filter them and take care of them. So rather than stirring the box of confetti here with the VAV system, a displacement system will kind of just push them up and away. So the person-to-person mixing and transfer is greatly reduced. Here's an example of a project that we did in Chicago. It shows the displacement system in action. So this picture here is how it was integrated into this casework. So aesthetically, it looks very good. And here's a thermal image that shows what's going on here. So here we see this nice, cool, clean air. It doesn't blow, it does not make anyone cold. It just kind of crawls across the floor and it's just filling up this lower portion with nice, clean air. And then until it finds a heat source. So in this case, it's the computers here. So once the computer heats the air, then the air will go up to the ceiling where we can safely remove it from the space. And we can see back here, we can see other areas where the system is working really well. So much better in terms of acoustics, much better in terms of air quality. And also, if we push all this heat to the ceiling, then we don't have to cool it. So generally, these spaces can save about 1/3 in cooling energy use in this environment as well. So ASHRAE gives it a 30% credit for ventilation effectiveness. So it's improving the ventilation in the space. And then there's so many other benefits that come with it as well.
Yeah, great. So moving on to conference or training rooms, areas where we gather together to use the space as one, I'm going to hit on electric light quality, and then I'll pass it back to Adam for more on thermal comfort and air quality. When we talk about enhanced light quality, there's several different aspects to this. And one has to do with lighting control, flicker, the quality of the light that we are using in the space. But we also talk about glare reduction from LED sources, and then also from daylight and controlling daylight within our space. And the last kind of concept within this realm is biophilia, and how we use lighting in different applications, distributions, rhythms, and methods in our space to enhance more natural environments. When we consider glare within our spaces, as Adam touched on already, we have the issue of maybe too much natural light within the space that we may need to control. But we also, with electric light sources, introduce more sources of glare into our interior environments. And while LED sources are a great form factor, you know, we love the application of it, they're incredibly energy efficient, they can tend to be really bright. And I think a lot of us have experienced discomfort glare from electric light sources within our interior environments. And so it's important to consider, you know, the quality of light that we introduce in spaces, especially where we have high important visual tasks that we're trying to achieve. So a rating system that the IES has come up with is Unified Glare Rating. And this is a rating given to luminaires based on their distribution, the angle, and the output within that angle. And so what we're looking for within office type environments is a unified glare rating less than 19 for a general application. And that's where most people find that the lighting is not too bright. For well, there's some different unified glare ratings to attempt to achieve to get the credit, but this is all about controlling lighting within our space and putting it where we really need to use it. So another method of controlling glare within the space is to use a layered lighting approach, where we talk about ambient lighting and focal task lighting to put the lighting where it's needed and not just blast the whole interiors with a bunch of light. Another integration for lighting that can bring a lot of comfort to spaces is integrating acoustic elements. And there are a lot of products on the market now that can incorporate lighting in them, or that could be used in conjunction with lighting to provide this overhead effect. And what we've found is that it's attractive looking, and it often requires a high density of this acoustic material to be effective or hit sensitive targets. And so we can talk about this a little bit more later in our presentation, but we do find that the materials are larger and require a higher density spacing through the space to be effective. This is what I was referring to, our acoustic integration at our own IMEG office. This is the same case study that I referenced before. This design, where you can see we have illuminated acoustic fixtures. We had planned to have also non-illuminated sections in a pattern to kind of create this whole dropped ceiling effect. And as we all experience on projects, we had some VE, and the non-illuminated acoustic sections ended up coming out. So here we still get the benefit of some attenuation in the space. It may not be enough. It's not enough here in this case to achieve more sensitive acoustic targets. When we talk about enhanced lighting control, the electric component of the lighting control, within spaces, this can really contribute to how people are able to interact and use the full functions of their space. You know, we design these rooms for different lighting scenes or different AV functions, partitioning that may need to happen within these types of spaces. And if the controls are not logical and well designed, they don't work well, and we end up not being able to use these spaces the way that we'd like to use them. And so here, when we discuss enhanced lighting control, we talk about a lot of automation in the controls, and automation to a point where When the partition closes, the AV and the lighting scenes can separate between the two rooms and be used independently, but not so much automation that people don't have enough personal control of their environment. So down in the left-hand corner, we show a nice control station that groups together the lighting, the AV, and possibly even the shade control to make it really an intuitive way to control our environments and our interior environments and make them most functional for the way that we want to use them. Back to our IMEG office, we had several of these strategies incorporated in addition to the lighting design for circadian support. We have a fairly sophisticated lighting control system where we incorporated dolly controls, which allow for individual addressability and the ability to change things as we grow into the space. And so, especially with respect to our case study where we're testing the wellness attributes of our circadian lighting system, we can make adjustments and fine tune things as we move along. We also have, as you can see in our conference room, a layered lighting system with indirect lighting, direct lighting, and really putting focal lighting where we need it. And this is all controlled with a scene selection system to make it easy and intuitive for users. So we really tried to take all of our wellness design and implement it into our new office so that we can have it as a case study of real world ways to measure how this affects well-being of people within these spaces.
Okay, halfway through. Hope you're all still with us. And yeah, this is definitely a content-heavy presentation, but our goal is to be holistic and showing a lot of different approaches that we've seen or we've heard from our clients, or we've heard from different architect firms around the country as well. So I assume that the questions are coming in through the chat, and we can certainly pick them up as we go along. Okay, so now we're going to take a little deeper dive into indoor air quality. We talked a lot about displacement ventilation system, but there's a lot of other things that we hear a lot about right now. Do I need to ventilate more? What level of filtration should I use? Do I need to put UV lights in my HVAC? What about bipolar ionization? What about increasing humidity? And then can we monitor for these things? These are all questions that we're hearing a lot about. So in this section, we're just going to kind of dive in just to kind of give the Cliff Note version of where we've experienced all these things to be. And hopefully at the end, we can talk about maybe some of your experiences as well. So the first one we talked about for the office space was this displacement ventilation. Here's just another graphic showing it in a conference room. Now I can't imagine when the day will be when we can pack a conference room like this again, right? But it'll come someday. And when it does, what does that mean? Because there's still things, people are going to think about spaces differently, I think, even after COVID is over. And what can we do to help, again, keep indoor quality solid? So here, this nice, cool, clean blue zone at the bottom, you push all the junk up into the red zone at the top, and then you kind of suck it away with the air handling unit. That's the overall strategy that would work pretty well for a conference room setting also. The next thing we talk about is increased outside air. So we've definitely heard a lot about this. And the idea with this is that, you know, all those pollutants that are in our space, you know, there's a ratio of good air pollutants to bad, right? The good ones are the ones we bring in from outside that are nice and clean. The bad ones are the stuff that we bring into the space. So whenever we increase our outside air, we're just changing the ratio. So we've got more good stuff than bad stuff. So we're trying to make it a small fish in a big pond instead of letting that particle be a big fish in a small pond. So outdoor air is a great temporary measure to do this. There are some caveats. Certainly treating super hot or super cold air is very expensive from an energy perspective. So we don't want to trade, you know, CO2 and climate change for every indoor environment. So there's some balance there we need to think about. It can be very effective though as a temporary measure, like at times that there are heightened alerts like COVID. You know, the other thing to think about with new construction, we can design to be able to treat outside air. For existing buildings, sometimes the coils can't fully handle all full outside air. So there's several things to think about, but we understand the benefits, and then we know how we can adjust for that in our designs. The second one is the filtration level. So we hear all about Merv this, Merv that, what kind of Merv rating do I need in my filters? And generally, the smaller the Merv rating, the bigger the hole is in the filter. So the more stuff it'll let pass. So like Merv 1 through 1, pollen is actually a pretty big particle, and we can catch pollen with a fairly light Merv rating. Even a lot of construction debris and particles, if you can see it in the air, then it probably gets caught by a Merv 1 to 4. As we move to the left, the holes in these filters get a lot smaller. And as the holes in the filters get smaller, we capture smaller stuff. You know, and so when we talk about bacteria, sneezes, viruses, the general recommendation right now is to target somewhere around a MERV 13 to MERV 16. MERV 13 aligns with lead requirements. And then these higher MERV ratings certainly can get smaller stuff. We hear a lot about HEPA filters. The HEPA filter was actually invented for nuclear fallout shelters during the Cold War. So it was intended to filter out radiation. And that's a very, very small thing that is likely overkill for what we're trying to do here. Healthcare settings do use HEPA. If there is a heightened concern, you can certainly, in a new construction or new air handling unit, designed to be able to use a HEPA filter, but those filters are very small, so that fan has to work really, really hard to push the air through all those small holes. So sometimes these existing systems, there's only a certain level of MERV rating that we can achieve. So in general, what are we talking about here? We're really targeting this MERV 13 to 16 in this type of environment, or we're looking for the best indoor air quality in our space. And then there on the bottom, these things, it's best if we can just eliminate from these from the site entirely, then we don't have to manage them. Okay, so now we'll get into UV lighting a little bit. Tammy's going to have a section on in-room germicidal UV lighting. And that generally is recommended as the most effective approach for inactivating COVID. We're getting a lot of questions about putting it in the air handling units. And then the question is, it helps a little bit, or the answer is that it helps a little bit. For years, we have put UV lights in our air handling units. And the reason for that is that cooling coils create moisture, moisture breeds bacteria. And when we give that bacteria a continual dosage of UV, it kills it and cleans up the coil. So it prevents mold and prevents other problems. So it's been effective for that. The issue here is that with treating the air, is that air will move very fast, very quickly through an air handling unit. And in order to deactivate a virus, there's a dosage requirement. Think about it like, you can't go outside for 3 seconds and get a sunburn. You have to kind of stay out there for a while, then the sun will eventually do its job on your skin, right? So if we want to do our job on a virus, we need a certain amount of dwell time where it sees this light. And generally, it just moves through so fast, it just can't always clean it all up. And also, only a portion of the air from the room actually makes it back to the air handling unit. So while it is killing some, it's not treating the whole room. There are some creative ways to put more of these lights into the ducts so that it sees light for longer periods. And it can help, so it doesn't mean that it's off the table. But generally, as Tammy will get into, in-space lighting does have some more benefits. Okay, so the next popular topic we hear about is ionization. And some owners have already started to put ionization in. This one here is a high-rise in Chicago that actually opened right at when COVID. The building was open when COVID came, and then they retroactively put in some measures. So you can see that blue apparatus there on the right is the ionization. And the idea behind ionization is that you can introduce an ion stream into the air. And what will do is it'll cause these particles to attract to one another. So when these particles are very small, they kind of just float in the air and they're happy there. But once they start attracting to each other, they start to mold together, they get heavier, then they basically fall into the bottom of the duct. So it's effectively removing particles from the air by forcing them to come together. And so it does have our healthcare clients, some of them swear by ionization, and that's their primary air cleaning method. When it does come to COVID, though, or these viruses, the jury is still very much out on whether or not this does anything to deactivate that virus. Some manufacturers are pushing, say it absolutely does. Some say that it don't. And so the jury is still out as to whether or not it's effective. So certainly if people do want to, owners do want to put these in their buildings because they want to try to do something, it is an effective strategy, but it's just important to know where the science is at with that. Okay, so now humidity. This is kind of the last topic in this section. And so how does humidity help with indoor air quality? How does it help with viruses or bacteria? So generally, you can picture if you were in a dry desert environment and you sneezed, you can imagine that sneeze and those droplets potentially just going on into the air forever. On the flip side, you could imagine yourself sneezing in a swimming pool. And when you sneeze in a swimming pool, it doesn't really go past the end of your nose. It's very close to you, right? So the air in our buildings is somewhere in between us, it's something less than a swimming pool and something more than a desert, right? So there is kind of a sweet spot here where if we have enough humidity in the air, we can get the benefit that um, what leaves, basically whatever leaves in our sneeze will not go very far until it falls to the ground, or it'll slow itself down. It won't spread as rapidly. So, for all these different things on this slide, that sweet spot is about 40 to 60% relative humidity. And in a lot of warmer, humid climates, our HVAC systems generally are designed to deliver 50% humidity. But in the wintertime, it's certainly less. And certainly in the Colorado climate, you're probably seeing a lot of indoor environments that without any humidification added are in this 10 to 20% range. So certainly on the lower end of the recommendation here. So in that case, you would need to add humidity if this is a strategy you wanted to use. Humidity, certainly it's can be expensive to generate, so there's energy implications. The other aspect in a cold climate like Denver is that if you have cold windows, you have cold surfaces, those can condense if we are too humid, and then you create mold. So that's just a different set of problems too. So it certainly can be designed for and planned for, but there's just a few considerations there. We haven't been hearing about humidity as a measure as much as these other ones, but it is certainly out there as a strategy. And then finally, monitoring and transparency. So the well standard has gone a long way to kind of push technology along in terms of being able to monitor our space. This is our IMEG Denver office, and which is well gold certified. And we used AWARE sensors in the space to monitor these different attributes here. So temperature, humidity, CO2, VOCs, particulate matter. Unfortunately, there's not a COVID sensor. That'd be pretty awesome, so you can see how much COVID was in the space, but we don't have that yet. So absent that, generally speaking though, if we know what our targets are for all these different levels, and if we're keeping all of these under control, in general, we can think that our HVAC system is doing a good job keeping our indoor air quality at a high level. So if these are level, or if these are fairly low, then there's probably a good chance that we're handling control of virus and bacteria in the space as well. So this is a nice, easy way to look at it. Green means I'm good. Orange means there's something I need to look at. So from a building owner's perspective, they can use this back of house as like a building management approach, or do you put it out in your dashboard so that people can see, oh, look, this place, they really care about me. They care about my health. I can see right here that my space is green. So that means I can feel good about where I'm at. Okay, so in summary, just kind of put all this back together. Number one was the displacement system, increased ventilation as a temporary measure, filter as your system would allow it. UV we'll touch more on later. Ionization, journey is still out. Humidity we just talked about, and then now transparency achieved through monitoring. Okay, so now we're going to jump over here to amenity spaces. So I'm going to touch on really quickly local food production, and then Tammy will jump into biophilic design and a couple other topics. So one thing, whenever we do finally get back into our buildings, back into our offices, this connection with people that we haven't been around for so long is going to be real important. And certainly even getting out of your house and away from that environment into a new environment, we're going to be looking forward to being with one another. So all these high air quality things that we just talked about certainly apply to these amenity spaces. The other thing we want to talk about is this connection to our food source. So when we share meals with other people, they connect us to one another, and they also nourish our bodies. So what can we do if we've got all these great features in our office building? How do we kind of round this out and add even more wellness to our space. And one thing to think about is local food production. So, a lot of us know that a lot of our food comes from hundreds of miles away, and people are concerned about that from an environmental footprint perspective, from a sustainability perspective, for sure. And now in the days of COVID, it's changed even more to, well, how many people have touched this thing before I ate it? And so there are some really strong reasons to think about local agriculture and local gardens. They also promote job creation. They bring buildings together. They bring communities together. Or in an office tower, they can bring different floors together here. So thinking about how to integrate these into our spaces, whether it's on the rooftop or if you've got some space outside, that that certainly works too, can really go a long way to talk about sustainable food, equitable access to healthy food, and just provide a really nice benefit for the people in the space. One example in this vein is a project that we did in Chicago with Method. And Method is you've probably seen a plant-based cleaning product manufacturer. So they have a very strong sustainable ethic in terms of creating cleaners that don't disrupt the environment, right? And then Gotham Greens is a national company that looks to grow food using aquaponics in this case, in an urban environment, and then supply it to local restaurants and other places. So Method was building this big distribution center. It had a big empty roof that was basically, not really doing a whole lot other than keeping the rain and snow out. Gotham Greens needed space. And so they got together, they put these two ideas into one. So now the owner of this building gets to make money by leasing out the roof space. People that come to Method to see the factory now learn about Gotham Greens, and then people that come to Gotham Greens to learn about the food now learn about Method. So it's it's just a really nice forward-thinking way to just think about our buildings a little differently here, and these shared ideals, these shared missions can really come together to make the space very productive.
Touching on biophilic design a little bit, this is not just a buzzword in the industry. There are actual constructs of biophilic design that we can bring into our interior environments to give people a greater connection to our outdoors and the natural experiences that over tens of thousands of years we have been entrained to as humans. And so we know through research that there are some actual health benefits to incorporating biophilia indoors. And there's also some increased, people report feeling more comfortable in these spaces and wanting to spend more time in these types of spaces. So increased dwell or linger time may be something that could become more valuable to us as we go back into our interior environments. What we are showing here, this chart on the left shows kind of three different constructs of biophilia within our interiors, and then the 14 patterns associated with those constructs. So when we talk about biophilia, we are talking about nature in the space, and that's plants, animals, water features, even the sounds that we hear that are directly in the space and are directly stimulating our sensory, different sensory elements. We talk about natural analogs too, and that's, forms and patterns and shapes or material elements that could be present that are evocative of nature within our space. And then lastly, we talk about nature of the space, and this is the actual layout and construct of the environment, whether we can we like to have spaces where we can have a view and be able to see out and see the boundaries of our space. We also need spaces of refuge in interior environments where we can have a moment of privacy or intimacy. So all of these different elements kind of come together and help to evoke, these primal instincts that we have been entrained to as humans, and we've lost connection to over the past number of years, spending a lot of time indoors. And so, this is a great shot of just different ways that biophilia is incorporated into the space, connecting people to the outdoors with views through the windows and natural daylight, but also the plants and the shapes of the luminaires, just being very natural and something that we would be expecting almost to see. So this space is a really successful example of bringing biophilia indoors. Another thing we're seeing is what we are calling hospitality supported workspace. And that's even within our office buildings or the buildings that we're used to interacting with, carving out these hospitality spaces where it's almost like a living room environment where maybe the materials are a little more soft. There's definitely more opportunity to bring biophilic elements in here, to have a variation in the lighting intensity, have more focal lighting where you need to see, and have warmer, more volumetric lighting to fill the space, to bring comfort and to really just support that people use these spaces so often. It's nice to take refuge somewhere other than just your desk and your working environment and your task environment. So carving out these kind of spaces within our office buildings can really bring a supportive feature to health and wellness. And lastly, we're going to hit on fitness, which again, like Adam said, we're going to discuss here disinfection lighting, which can be applied in a number of different types of interior spaces. Fitness is a good one where we can imagine people are there to be healthy and remain healthy. And it's also an environment where germs can be easily distributed. So disinfection lighting, specifically, we're going to talk about ultraviolet germicidal irradiation, UVGI. This is the method that's currently recommended by the IES as being the most effective way to provide disinfection lighting in a space. It is also the only method, UVGI is the only method to inactivate virus within a space. So there are other methods of disinfection lighting, specifically 405 nanometer antimicrobial lighting, but those are ineffective against virus molecules. And so we're going to focus on the UVGI, the UVC lighting that inactivates viruses and can be used in a number of different environments. It has benefits which are not new to us at all. This technology has been around for over 100 years. It's also been shown to be incredibly effective in the reduction of tuberculosis, which is an airborne virus similar to COVID. At this time, we do know that UVGI is effective against COVID. It does inactivate COVID molecules. We don't have peer-reviewed data out right now that gives specific dosing recommendations on COVID. But because of what we know about tuberculosis, we know that a lot of this science can be applied to a situation where we're trying to deal with COVID specifically. So how this works, we are in the UV spectrum of light. So we're outside of visible light, even beyond UVA and UVB light. We know from wearing sunscreen that UVA and UVB are carcinogenic wavelengths that come from the sun in our environment. UVC, however, is not naturally occurring in our environment. And so it's at a further side of the spectrum. And we know that this is effective at inactivating virus, bacteria, fungi, and mold. We also understand that UVC is, there are limits of exposure to humans that are considered safe. And so, you could potentially be overexposed to UVC light, and side effects of that could include some temporary snow blindness or even sunburn. Architectural implications of considering a disinfection lighting system really go into the the types of surfaces that are present in the room, and considering how those may degrade over time, and also their specific UV reflectance. So, you know, we know, especially living in Colorado, that UV light can, when it's intense and prolonged, it can cause fabrics to fade and lose integrity, and cause plastics to yellow and degrade over time. And so when considering a UVGI application, it's important to consider the materials that are in the space and a potential compromise in their lifetime from being exposed to more UV light than would normally be expected in an interior environment. The second consideration, oh, I'm sorry, Adam, is the reflectance of the materials within our space as well. And so, you know, in order to limit the exposure of anybody that's within the space within these rooms, we need to make sure that we're not bouncing a lot of UV light or UV energy off of other surfaces. And so one interesting thing to point out here is that we found a variation in ceiling tile UV reflectance from anywhere from 4 to 46%. So this could be a really important material to consider if you're going to install this within the space. Upper room UVGI uses luminaires mounted high on the walls, directing radiation out into the space. The theory is that the air recirculates in the room and warm contaminated air rises up into the disinfection zone, gets cleaned, and then is recirculated into the room. So this is a system that works actively. It's considered safe when properly designed and installed within a space, and it works continuously while the source of contamination is within the room. Another method of applying disinfection lighting is a direct UVC method. These luminaires are a little more architecturally appropriate. They look like luminaires that we're already employing in spaces. But the major consideration here is that people cannot be present in the room while these have direct UVC light coming out of them. So it's effective, it disinfects surfaces and the air within a room. However, it does not mitigate the source of infection if there was actually an infected person within these spaces. And the last thing to point out here is that UL just came out with a new rating system on direct UVC systems. And so it's important when considering these systems to look at product that is UL compliant. And the UL requirement really requires this controls lockout in addition to properly installing the luminaire to where people cannot be present while the luminaire is in operation.
All right, well, thank you for sticking with us there. I know it's a content heavy presentation, but our goal here is to just kind of direct towards the office of the future. So as we think about our spaces, COVID, post-COVID, or just wellness in general, there's a set of strategies here that we feel are really important to consider, either holistically or in part. So that concludes our portion. So I guess we can turn it back over for questions.
Awesome. Thanks, guys. That was a lot of stuff. And it was well paced. So good job. Sometimes, it gets a little too fast and you feel like you're drinking from a fire hydrant.
Yeah.
But nicely done. So while we're waiting for some participant questions to queue up, just a few notes. Well, first of all, you're one cool customer, Eric, or Adam, if you're at 92 degrees when you're going to vote.
Yeah.
So, I really appreciated the notation on the open staircases. I think that was a trend that was already happening and may really accelerate. That COVID accelerates a lot of things that we see in society and in the built environment too. So I took note of that. I think we'll see more of that. We haven't heard relative humidity talked about much before, other than occupant comfort as a safety, a health safety thing rather than just the welfare piece of it. So I expect to see more of that. A question just on something real recent. Tammy, you talked about the control lockouts for the types of germicidal lighting. Would that be could that integrate with motion sensor technology, for example? You know, if somebody's in the room, it shuts it off.
Yes, and that's typically the method too, is to use a motion sensor to detect occupancy. And then also there's sensors in the doors that can be installed, you know, to where if that door were to open, the lighting would automatically shut off. We've looked into two open office applications. What if there is no door, and you know, what threshold would the occupancy sensor need to see somebody? And manufacturers are using also like laser pointer systems, like the sensor on your garage door opener, to where if you cross the boundary and you trip the line, the UV lighting would turn off.
Yeah. A really interesting takeaway was early on, he talked about green buildings versus a typical building and the occupant performance levels. You know, so, I mean, those are not little deltas, those are huge deltas in terms of their cognitive function and their productivity in the space. So we've heard a lot of talk about making a business case for sustainability, which is more about, you know, bottom lines, you know, let's advocate for more policies on tax credits or expedited permitting or things like that. But wow, that's a really compelling argument to my eyes. Just think about how much better the people who operate in that space are going to be at their jobs, or not even jobs, in a learning environment, for example, in schools and universities. We'd love to see that more widely talked about.
Yeah, absolutely. And as we return, you know, to the office environment, if employers want to see their employees back in the workplace, it could be a selling point to the people that work for them too.
Yeah. So on the, you talked about monitoring and transparency. So who monitors? Do you need any sort of special training to look at that dashboard or calibrate it? Is it complicated? And then the follow-up to that is, you talked just a bit about this. Who sees it? Is there an advantage to letting any occupant of the space see the monitoring and how it's performing on a daily or hourly or even real-time basis?
Yeah, I mean, I think the way the dashboard's configured is, you know, varies by manufacturer, and there are from only probably 2 or 3 really vendors maybe 4 or 5 years ago to now, you know, being a lot of different products out there. And I think this one, the Airware product, is nice. What's really nice about these systems too is that a lot of them set up where you just plug them in an outlet and then you network ID them into a mesh, and then it just takes the data and pushes it onto an online dashboard like this one here. So it's fairly easy to set up. A lot of these vendors do it as a software as a service, so it's instead of a large upfront cost, you can kind of integrate it over time. So I think this one is just a web address, so all the employees in our space here have access to it, and then there is a dashboard out in the space for people to look at it too.
And I'm a user at this office. It's my office, and so you know, as an employee, I see the monitors, I see the green light. Looks good to me. You know, prior to COVID, it wasn't really something that occurred to me that I might need to monitor. But knowing that it's there and knowing that I could look at the dashboard does reinforce to me that I'm in a healthy space, and that, you know, it's being considered. And even if it's happening while I'm not paying attention, I know that it's there.
Yeah, it could potentially be an employee recruitment and retention tool. You know, it differentiates you in the marketplace right now, because there's probably not a lot of people using this, and it reminds me of the modern equivalent of the truth window. You know, when you would show people what's behind the wall board, for example. Right. This is kind of the same thing. You know, what that mechanical room makes some noise all day, but I don't know what it does. Here's what it does.
Yeah, and it's outcome based for air quality. We don't usually have that. We kind of just say, well, we design HVAC and it should be good, and they never close the outside air damper, right? Right. And you know, here we actually know it's working, and so there's a lot of power to that. And then kind of the data nerd into me, you know, if we've got hour by hour level of VOCs and CO2, and then we know the productivity gains, we could actually calculate an actual annual bump in productivity in dollars, right? Because we have the data now available to do that.
Are you seeing, when people are trying to, I bet mechanical engineers are getting a lot of inquiries about the HVAC systems, and you know, the low hanging fruit is change your filtration. Or is there any trade-offs there, or some maybe pitfalls on things like, if you upgrade your filters, what are you doing on your pole load on those motors? Are you changing your maintenance intervals, or even your long-term operating costs when you do things like that? And then what's the better long-term solution between a MERV or UV or an ionization?
Yeah, that's a great question. So there's several questions in there. So on the filter side of things, a lot of like VAV type systems that were put in, and I'd say in the last 10 years, generally they operate at like 50% of their full load. So the chances are pretty good, if it's a recent system, that you could up the filtration and the fan can overcome it. And especially if it's operating lower, the way that the fan works, it's like cubic. So the further down you get, it uses much less energy. So if you add a little bit of more friction through a filter at a very typically low operating range, I'd say overall that impact's pretty low. And I think the benefit for MERV 13 is absolutely there, because you're just catching things other than pollen and large particulate matter. You are starting to get at some of the bacteria and stuff. So I feel like that's a good trade-off. You want to check to make sure it can handle it, but it's okay. As far as UV versus ionization, I questioned a little bit the effectiveness of both of those. UV has a much higher power draw to power these lights than it takes to put ionization into the air. So I think it's on the order of 5 or 6 more for UV. So just strict operating cost for these two items is probably on the order of 5 or 6 for those two things. But yeah, if you were to stack those, I would say the filters first, increased outside air. That's what gets to those productivity metrics too. So even if you don't want to go 100% outdoor air, increasing that 20 or 30% would be number 2. And then maybe you start to look at, these two things maybe next.
Okay. Well, let me check the dashboard here. A couple more, and then we'll wrap up. I know it's a lot of the examples you used were for new buildings, new construction. What about for existing buildings? Are there some things that can be done there? Most of our space that's utilized right now is existing square footage.
Yeah, so I mean, some of my favorites is I think daylighting is low-hanging fruit in most existing buildings. I think we keep our blinds down, or I think we just choose darker colors, or we choose things that limit the amount of daylight in our space when it shouldn't be. I even walk around in my neighborhood and how many different blinds are closed in places, and there's just a disconnect there between making that available. So I think that's definitely there. Probably 2 or 3 of these HVAC measures we discussed are available as well. And Tammy, I would assume you have some lighting wise.
Yeah, I think the ultraviolet UVGI lighting can easily be retrofitted into a space, and it may require some painting of surfaces and maybe a few other considerations, but it would be simple to retrofit. Not that it's inexpensive, but it could be certainly added to an existing building. As with any lighting upgrading lighting or lighting controls can be a more superficial upgrade to a building. But yeah, like Adam said, I think it's being intentional about these things may exist already. It's as simple as raising the shades or designing some shading system that makes the daylighting more comfortable. Utilizing things that are already in our environment to a more intentional aspect in our spaces.
Well, I definitely think people who've worked from home for a matter of months, whenever this is behind us and they start to go back, the one thing they've appreciated is access to outdoors, whether it be their own backyard or porch or deck or patio or just a short stroll around the block. So I think the buildings that house people for work are going to have to address those as well. Even if you can't be outside, it should feel like you're in a more organic or biophilic space. So it's definitely worth considering going forward. And I really appreciate that the thrust of this presentation and where the industry needs to go is that it's not about doing no harm. It's about elevating and enhancing the experience for everybody.
Mm-hmm.
So that's my takeaway. That's what I'm taking out of the Be Well presentation for today. And I hope that was what you intended.
Yeah, great.
Well, this is a great presentation. Very much appreciated, Adam and Tammy. And thanks also to IMEG for all your support of AI Colorado over the years. We appreciate it. We know you were back this year for our signature programs, and we'll be doing those again too. So we look forward to hearing more from you. And for everybody looking forward to more from AI Colorado, we've got next week's Virtual Connect is an architect quiz. What do you know about health, safety, and welfare? It's hosted by USI, and it's how to integrate health, safety, and welfare into your project and your firm. So important stuff as we close out the year. We're wanting to load up on your HSW credits for people who need that for licensure. And this is just one of those. So thanks again. And the last reminder I'd give to people on the call is bylaws voting. Other exciting stuff for rules of the road opens tomorrow, November 5th. So watch for that. Thanks again to everybody who joined us, and especially to our presenters at IMEG.
Thank you, Mike.
Great, thanks, Mike.
Have a great rest of the week.
Bye.